Yeah.
How experienced are you in Arduino? All right, okay. I mean, this is a basic workout, so.
Yeah.
Okay. You're a high schooler, it's for free. Yeah, appreciate it. Okay. And, yeah. So, can you computer out? You have a computer?
I didn't bring two computer class.
Okay, we can do on my computer afterwards, or your computer.
It's my fault, I forgot to post it on the.
It's okay, I also kind of forgot about that part. Okay, it's okay.
No, I do not have computers, sorry.
Okay. We'll go through the steps afterwards, so we can go through. All right. Okay. Let me open up the Explorer real quick.
This was a little bit mistakes.
All right. Let's get a little started. Hello, everyone. I'm Yash Karwal, and this is our Arduino workshop. Welcome. It's going to be our last workshop for the year, most likely, at least just ourselves. And the next workshop will be the Raspberry Pi with the MIT. So after that, we're going to be, that's our final workshop. All right. So before we start, instead of last semester and this semester, how many people know about Arduinos? I know I already asked you before, I'll ask you again. How many here I'm recording. So how many here have any experience with Arduinos? You guys all know what it is? Okay. So just to go over, what is an Arduino? So an Arduino is basically a open source, microcontroller that you have, something like this, right? Most of the time you'll see something more generic, like you've all heard of the Uno, the Mega, right? This is similar in the Uno, but a little different, it has two different chips. But it's used for digital prototyping and controlling different little electronic circuits and projects. It can be ranging from a lot of different things. We'll go over that in a bit. But yeah, they can control motors, steppers, sensors like load cells, potentiometers, like volume knobs, and other stuff too. Okay. So on the Arduino, you've seen the Uno R3. That's like the generic one that everyone uses, right? That one has this big fat IC right here. That is the main CPU of the Arduino. So it's called the Atmega 3228P. This right here also has the same board, but you see it's a lot smaller in size versus that big one. Because this one here is a through hole, this one here is surface mounted. So this one here is the same size or same type of processor as that one. And there's also stuff like the Atmega 32U4 over here, which is actually also on this board. So this board has two different processors you can use for your projects. Right. So here's schematic of the Uno R3. You guys all probably familiar with this. And so each Arduino will have different constraints on it, right? The Mega is a lot bigger, has a lot more power on it. The processor can scope up faster than the Uno can. So size, processing speed, and power all matter depending on your project. You may want a smaller one for smaller projects that don't require as much power or as much computing, but just maybe turning off a simple light on or something like that. Versus something like this, which is your intermediate kind of stuff. You can do anything ranging from small things to maybe a few controlling aspects, right? So before we get to hardware, I want to show you guys a little bit of what you can do with the Arduino, just to give you guys a little introduction to what it is. So I have a few of my own projects that I've done before. So it can go from ranging from this. Hold up, let me escape and show you this. So this right here is a stepper motor controller. So this is a stepper motor, and you can control that using this H-bridge driver over there. So what I'm doing here is actually sending pulses, because this motor is not a simple DC motor we just plug in and play. You gotta send a pulse, a little waveform, and that tells the magnets to turn on and off. at different speeds. So this is going to be used for well, it was used for a different project for launching a ping pong ball autonomously, kind of, but yeah. And then you can go from there to maybe even do something like this, where you have a Mega, and you have a little Bluetooth module over here, and you can use that with the little H bridge over there to control the servos. You can make an Android app, and then use the Android app to control the servos. So you can make something like a Bluetooth controlled, well, some sort of Nerf turret, but I didn't make one in the end, but it was going to be something like that. Also, small things like this right here is a force sensor. Just to measure how much force you're measuring. So what a force sensor really is a resistor that basically changes and deforms, right, as you press on it, there's more forces added, right? And that'll change the resistance in the actual, because like depending on the length and how the resistor is, it'll change how much resistance it has against the current, and it'll output different amounts of voltage. So you can use that to measure something like, let's say, how much force is occurring through a rocket engine, which we'll get to in a bit. And then this here is to control LEDs, because I'm kind of a god at LED control at this point. So this is simple, like toggle, right? But this was later used, same circuit, just a little bit more added to it, to make something like this, which is a lamp. So here I use the 3D printing part of our workshops, right? CADing part of our workshops and custom stuff, translucent, filament over there, and make basically a fader, a lamp, which has like 11 different modes on it for some reason. So, and then here's like a audio reactive one. So here uses a Java program that I use on my computer, sent it over to the Arduino using serial, so the USB, and then whatever I'm streaming on my computer, it will output it there, and that's highs, the mids, the lows. So it's a different project you could do as well. I have a lot of projects because I'm kind of skimming over like things you can do, right? But in the end, you can get something like this, which is for a feed system. So this was actually pretty recent. It was actually this past semester I was working with. I'm getting all this data, pressure data, motor data, or the solenoid data, so what state each is. And what we're doing is we're creating a feed system for our rocket engine, because it is a two-propellant rocket engine. So it has a solid rocket motor and a liquid rocket motor. The liquid rocket needs to be fed through the feed system, pressurized, and went to the rocket, the engine itself, which is on the floor. So he's opening up all the valves manually first, and then there's like 3 solenoids at 3 different parts of the feed system. If you guys want to watch this whole thing, let me know. Well, I can skip through it. So I'm gonna skip through it right now, but if you want to watch it, let me know. So later on, you'll see the engine is actually on the floor somewhere. So right there, you see our, where's it? Oh, I missed it. Okay. But there's 2 Arduinos working together with the Raspberry Pi to send the data over through Ethernet. So I'm not talking a lot right now, but the scale of the project really, it's almost the Uno. There's 2 Unos that are working together with everything else. So once you know a little bit about how things work, you can come together and make something large like this. And then I'll show you the engine though, real quickly. That's the engine of our rocket. And then in the end, it controls a separate motor right there, the separate motor up there, right? As the first video. So sending pulses over. And then it would let the water flow through it. And then you get something like activating. You get the water flow through it. And this ended up being for our actual rocket fire. Same system, but it's fully in there. And then we press the button for the solenoid once to activate from 300 feet away. And then ignite it. And then we feed the field through. So a lot you can do with Arduino. A simple one you can buy for 15 bucks, you can build a rocket. Theoretically, you can control a rocket, I guess, more of. So there's a lot you can do. I'm gonna close it for now. I can't see the close with it. Okay, cool. So that was also just to wake you guys up. Just kidding. But Yeah, so there's a lot you can do with the Arduinos, okay? So the possibilities are really just up to your imagination and the limits of the processors themselves. So let's get to the power or the pins. Let me bring it back. Okay. All right. So each Arduino has its power pins. You'll see them either as, for this one here, the Spark is called a Pro Micro from SparkFun. It's something that actually can control your keyboard inputs as well. So you can map certain switches to send keyboard functions or mouse movements. So that's a different Arduino you can use as well. But it has a raw, ground, reset, VCC, and ground. For your Unos, you'll see them more like V in instead of raw. You'll have V in, you'll have your grounds. Your reset, RC is reset. Your VCC, your 5-volt, basically, and your ground again. So your you can power this or an Arduino from either your USB port, your V in port, or your raw port in this case, or from the 5-volt and ground pins. Make sure you in those 5-volt and ground pins, or the VCC and ground in this case, you make sure you only put 5 volts through it and not something more, because there's no voltage regulator or anything to stop you from causing an explosion in the thing. I've learned from that because I think put 12 volts through, more like 20 volts through it. That was not fun. Everything's popped. All right. So the raw pin for this one, or at least the V in pin, I believe, for Unos, I think they are regulated by voltage. So you can put a 9-volt. Don't go over 12 volts, basically. Anything over 12 volts, you can cause it to explode. And don't ever put them the opposite way, because they're not reverse polarity friction is not there. And also the GPIO pins themselves, so any other pins you see, if you power it with anything higher than 5 volts for these ones, you will cause it to fry. So don't ever do that. And then there's other boards out there like 3.3-volt versions of Arduinos, the Raspberry Pis. They all work at 3.3 volts. So don't put 5 volts through their pins or else they will also fry. That's important to know because if you're doing communication between two different Arduino or controllers, right? Like for instance, for our case, for the Rocket, we had the Arduino and we had the Raspberry Pi, right? The Pi works at 3.3 volts, the Uno works at 5 volts. So that wrong voltage for the Pi would cause the Pi to freeze and almost eventually crash or explode, right? Because it doesn't want 5 volts. So you gotta be careful with your requirements for power, okay? There's other modules you can use for these boards that might be 3.3 volt only. So make sure you step down the voltage. That's something to bear in mind when you use these boards, because as long as you know what they can support and how much current they can support, you can do the rest. You can do whatever you want. These GPIO pins can only support to I believe 200 milliamps current. Your V in or your 5-volt pin, I believe, or I think the V in pin is your 800 milliamp source. So anything higher than that current, it could cause the entire board to heat up and fry. I think it's in the first video that I showed you with the servo motor. I actually ran the motor off of the V in pin of the Arduino, which is a big mistake. You never run motors off the V in pin or any of the V in pins of the Arduino, because motors require a lot more current. The servo motor requires 4 amps. And again, the Arduino is only up to 0.8, right? And then you have a problem with that, right? And next thing you know, your Arduino will overheat. In my case, my Arduino started smoking. But luckily I saved it before it fully died. So you gotta be careful. And yeah, so these are your GPIO pins or your general purpose input output pins, right? You have your digital pins. For most cases, all the Arduino pins are digital pins, which means they can send a 0 or a 1. They can receive a 0 or a 1, right? There are some analog pins as well. They're labeled as A number. So on your Uno, you'll have a whole row of just A pins. On this one doesn't actually show you anything because this is a special board. There's not fully Arduino. So you have the PC0 and PB numbers. So if you think of an Uno, right? on the right, on the left side, on the bottom will be your analog pins. When you label it in your code, it'll be A0, A1, and whatnot. So what they do is they have a 10-bit analog to digital converter. So you have 10 bits to store any varying data. If that makes sense. I wish I had an Excel for right now. But in case, let's say, you're going to measure a volume knob, right? You can measure it normally, right, by just putting some voltage through the resistor, because it's basically a resistor, potentiometer, right? So as you turn up the volume, you're just lowering the resistance. That means you're increasing the voltage, right? So the analog pins, they can take the voltage range that you have. Typically, it's only 0 to 5 volts because it can only handle 5 volts maximum, right? So we take the range from 0 to 5 volts and put it into basically 1023 different segments. And then that's going to be your fake analog range because it can only use digital or binary, right? It can't read values between like decimal places. Because that's how these all work. You have your PWM pins, which are your pulse width modulation pins. These are labeled over the check mark in the schematic. On the Arduino themselves, there'll be a squiggly line. They output analog values, or analog values in this case, using 8 bits. So it'll segment the 5 volts, 3 to 5 volts as 8, or I believe it's 255 or 256 different segments. And then that'll be your output. So, and it does this by basically changing the pulse width. That's what's called pulse width modulation. So if you think about it, you don't have an Excel marker, by the way. You really use it to write something because it's better to like visualize what you did. I think we'll go over it later on as well. So, but overall, this is how it works. And then you have your communication protocols, your I2C, UART, SPI. That just means UART is your serial communication, your USB, your TX-RX pins basically. If you look at this, the TX-RX on the top right, top left, that's your UART pins. SPI is a different communication protocol, and I2C or I2C is a different one as well. And okay, I'll use this more for the PWM signal so we can really see it. All right, but yeah, like I said, the ADC is the analog pins, and it uses basically voltage, different segments of voltage, right? That's how an example would be like for a rocket, we use the ADC pins to measure the pressure readings because the pressure transducers will only output a certain amount of current. So we change it into voltage differences and then see how much readings are there and calculating what it means. And same for load cells and everything like that. Yeah. PWM pins, like I said, they can output basically a fake voltage. Let's say you have only 0 and 5 volts, right? And you want to output 3 volts or something like that. So what I'll do is, can you guys all see from me on this board right here? So you have your 0, right? Your 0 volts. And then you'll have your 5 volts right there, right? This is your normal 5 volts, 0 volts like signal. Maybe for something on or off, that's what it does. For pulse width modulation, what you're doing is you're sending a pulse with varying bits to change for how long is it 5 volts? For how long is it 0 volts? So if this was, let's say, your time of being 0 volts, let's say that's your time low, right? And your time of being 5 volts, that's going to be your time high, because in stuff like this, in signals like this, your low is your 0 voltage or ground, right? And your 5 volts is high. So your time that you've set at 0, you're at 0, and the time you're at 5 volts, if they're equal, you're at half the voltage because half the time you're on, half the time you're off, right? So you're going to be at 2.5 volts. And we can test that later on to see that. So, and then let's say if you're on more of the time, but you're off most of the time, like this, you're gonna have a higher voltage because you're basically you're kind of tricking the system in this case to think it's at a higher voltage. Well, really, it's just blinking really fast or slow. So, yeah. Okay. Yeah. Here's a little graphic tip there about how the what's called the duty cycle is your time of being high over a total period that your signal is going for. So 100% duty cycle, this means you're always on. 50% you're off and on at the same amount of time. And then if you see 25%, let's say you're on for like a quarter of the time and you're off for 3/4 of the time. Right? Does that make sense, everyone? Okay. How about software? So to program the Arduinos, Arduino uses about C or C++, like a fusion of it. And many microcontrollers are compatible with the Arduino IDE. This one right here was originally for a different type of IDE. It's called the Atmel Studio, I believe. But we're going to convert it to use our IDE, the Arduino IDE. And I think the Teensy also uses the Arduino IDE, the ESP modules. They're a different type of microcontroller as well. So this is kind of like a bit more like if you want to learn something, this is your IDE tack to kind of go through. And then you can also use MicroPython, which is like a Python instead of C++, for more powerful boards like the ESP32, because the ESP32 is a dual core microcontroller. Yeah. And then you have different functions to work with each of the ADC PWM pins. Yes.
Circuit counting is also.
You can possibly try. Maybe, I forget, but it's not for Arduinos. They can't do it. But you can try with the ESP32. Yeah. Circuit Python? It's a language. Yeah. So you have normal C++, right? That's for Arduino, but Circuit Python, MicroPython, there are, I think, MicroPython is for microcontrollers. Circuit Python, I forget what that was for. But yeah. Okay. So let's talk about code. So in your Arduino code, when you first boot up, so let's all boot up the Arduino IDE if you have it. If you don't, it's okay. We'll look up here. We'll go through it later on. Right? Actually, we'll boot up right now. See if we can put the Arduino IDE on my computer as well. But when you first boot up, let's say it's called a sketch. That's going to be your first one. So I'm gonna show you. Oh, this is the what is this for? The BVM. We'll make a new file here. New sketch, right? So when you first boot it up, you'll see that all you really have is your void setup, your void loop, and that's it. So your void setup, it just runs the code once to set up all of your pins to their proper states. Whatever your default startup sequence is, that will be in your void setup. Your void loop is everything after. So in the void loop, it will constantly be looping that same loop for however time like the Arduino's on for. And it'll loop it over and over just so you can keep pulling data from your sensors or doing different things. So you got to make sure that you define everything in your setup, and then in your loop, you don't really define anything to reset it. So we'll talk about yeah. So you gotta make sure you're in your setup, or before your setup actually, you want to basically use that as your variable names, their declarations, initializations, function definitions, initializations, your library inclusions, all of your important setup stuff. You do that before you even start your setup. So just defining what names are gonna go where. So if you look at, let's say, back to, let's say, some of my old code, let's see. Let's look at this one. Right? So here, look at the very top are my libraries I'm using. In this case, I'm using the RF library and the SPI library for my communication protocol. And then I'm defining all of my variables, their names, what pins they're on. And then let's say other variables. So this right here is a constant. It's not a variable. It's just a constant to kind of define what my constant is. I'll go more over in detail later. And then structures, we'll go over that in a bit as well. But yeah, all my variables are being defined before the setup loop even started. Like you see my array right there. And then here's my setup. Now this is where I set up all the outputs. What are my outputs? What mod rate is my serial mod rate going to be running at? We'll go over that later as well. But yeah, just like my setup function is just starting code, just to let me know it's starting, it's booting up at least it's there to boot the code. Right? And then later on, I'll put some other stuff in between before my actual loop starts. But where is it? That's funny. I missed the loop. Oops. Oh, there it is. Yeah, so there's the void loop. And it's a simple toggle and whatever I'm doing with functions. So yeah. So in your setup, you want to put all your condition parameters in your loop. All of your mains like polling, whatever calculation you want to do that over there. So you guys have seen the hashtag define that I used for my the declarations. You can use that to kind of define your variables. So you just have to define the name and the pin or the value, what it set it as. It's kind of faster than doing like int name equals something and semicolon. So you can put out the semicolon in this case. Actually, I should ask probably who here knows how to program in C++? Yeah. All right. That's when the question starts off. Okay. Who knows how to program in general? Does. That way I know who has a lot of logic, at least because logic is important. It can carry over from like different languages. So yeah, but that's your define. So you want your variables, which can store the data that you want and carry it over to change later on. Okay. This is the pin mode function. You're going to use this function to basically set whether your Arduino is receiving data or is it sending out data, right? This is important because this can mess up later on if you set something as an output and you're trying to read something from that, and it won't be reading anything because you're set it as an output, not as an input, right? So it just changes the state of the pin using a switch and a pull-up resistor. And yeah, so most of the time you want the sensors to be inputs and your outputs to be, like so you can see there's stuff like input pull-up, which basically change your input from being, so normally your input, you have your value set as 0. Sometimes you'd want your default to be as a high or a 1 volt or 5 volts. So that's your input pull-up. You pull up the pin to high, so you send it a ground or a 0 as your 0. Does that make sense? Everyone understand? Okay. Okay. And so here is digital write, which is a very important function you can use. That's how you tell your output pins what value they should be outputting, either a 0 or 5 volts, or a low or a high. So that's you just put basically the name of your pin or the number, and then what state it's going to be. And then it's 5 volts or 0 volts. And then your digital read function over there is to get the data from your input pins. You just gotta put the name of your pin or number of it over here, set it to a different variable. You can store it and use it for whatever calculation you want to use. So we use this a lot for, let's say, you need to read the ultrasonic sensor. That's a sensor that sends out an ultrasonic, pulse. So really high pitched, sound waves that you can't hear to detect distance. So whatever inputs you get it from there, or a button, and then you output an LED if something comes too close to you. All right, there's also the analog read and write pin functions. These ones are, so analog write being you write out to your PWM pins. what value. So from 0 to 255, what value they should be. And analog read will be from your analog pins themselves. Basically 0 to 1024, how much they should be reading. So either you output, let's say, a dimming LED, or you input, let's say, a volume to dim the LED, either directly. And yeah, as I said before, the analog pin has like 10 bits. So it can kind of map out from 0 to 5 volts, about 1024 different values to kind of represent the different varying values of the analog reading. And then the 8 bits of the output to simulate the 256 different values for the voltages. And the higher the resolution you have, the more bits you can read, the more the higher the sensitivity is. For instance, like if you had, let's say, 1 bit only, right? A 1 bit resolution, that's just 0 and 1. That's your normal digital read, right? So if something's there, oh, so high. You can't really do much with it, right? If you had a 4-bit one, that's what 1, 2, 4, 8, 16, that's 16 bits, right? Or 16 different values you can use. So you have 16 different values you can use to represent the voltage ranging from 0 to 5 volts. So you want more to help like get to the more sensitive parts. So sometimes you might want to get a different module that has, let's say, 24-bit ADC that can represent a lot more bits than what the built-in one can. So, all right. And this is the map function. It's pretty useful for joysticks and whatnot. So like kind of, let's say you're getting a reading, but you want to convert that reading to something else, right? You're getting an input reading from your servo, from a joystick, right? That has a range from 0 to 1023. But you want to map it to the steering wheel of a car, right? But you can only output 0 to 255 different values instead. So use map to change the range from 0 to 1023 to 0 to 255. So you're kind of basically ADCing the ADC is what's happening here. And you can set that. So you can do that from anything. You can change the, basically, I use it a lot to get out parts of data of a range. Rather than having the entire range, I want a part of the range. So then, or I want, let's say, well, yeah, you can use your own functions for different other things also. All right, and then we have the hashtag include. This is going to be used for all your libraries and any other referencing material that your code should have. Libraries are very useful. They can help you do a lot of cool things people have built over the years. You can build your own library as well, import it if you want to. But yeah, so all these are already pre-built from like other people to use different modules. So you don't have to do all the hard work of going into the registers and addresses and whatever. You can just simple function and it'll do it yourself. Kind of magic. Yeah. Then this is the structure. Structures are very useful. Before I didn't use structures a lot, but ever since like I've learned a little bit about wireless communication with the NRF module. You can pack different types of variables all together. So it's like an array or a list, right? But with different types of variables. And then you can just send it over pretty easily, read it, write it. So this was used heavily in my rocket and in the engine testing. But yeah. And then we have our outputs. So yeah, everyone should know what an LED is, I hope, right? Everybody knows the longer one is the positive lead, small one's the negative lead. If you look inside of it, the smaller triangle is your positive, the larger triangle is negative in case you forget. So make sure you know they're polarized, so you put them the right way. Make sure you also have a resistor in front of them or behind them, about 220 ohms or more, probably 330. You just don't want the current that goes through the LEDs be over 20 milliamps, because then it'll pop and it'll be sad. There's also motors. So this is a DC brush coder. Pretty simple. All you have to do is positive, negative, and it'll run, right? But there are other motors that I've shown you. There's servo motors, the ones that rotate to an angle. There's one stepper motors, they rotate in steps and they work in pulses. There are brushless motors, which you can't just plug it in normally. You gotta use an ESC or something else. But yeah. This one here is pretty simple, so you can use this. Do not plug this in directly into the Arduino though, because as you guys maybe know that like you can turn a motor to create electricity, right? You don't want anything to go back into the Arduino that's higher than the voltage that it can, input. And so you want to use a resistor, some diodes, maybe even to kind of, in case when the motor stops spinning, isn't cause like induce a current into the actual Arduino, right? In my case, I just use a different motor controller to separate it out. That way, there's nothing coming back into it. Okay. And here's a motor driver. Pretty archaic, as according to many people nowadays, apparently. But it's very cheap. You can get it. It works. It's great. It's an H bridge. So this shaft here is the H bridge. So it's called a full H bridge because it can control two different motors or one separate motor. It can go forward and reverse. So it's pretty cool for your small projects. Let's see if you're learning something. We'll get one of these. They're pretty cheap, like $5-7 maybe. And then you can support with 32 volts maybe. Well, it's 32 volts around. I think it was same. But yeah, about 2 amps. But yeah, I think it was more like 30 amps. Maybe I could be wrong. Maybe I used it a bit too much, but yeah. And then you can also buy an OLED. So that uses a different communication protocol called I2C. So you have SDA SCL pins for I2C. We'll go over I2C today, possibly, if time. And then just communication with different people. But you can use that and their library for this to create your own little artistic stuff or controller. Any questions before we start the lab? Or already? Did everyone get an Arduino, by the way? Or you can wait. Do you have your kit, by the way, or no?
Yes.
Okay. Okay. We're headed back after. All right.
Oh.
So let's start. I'm going to put the Arduino IDE up here. All right. Okay. So let's go. Let me duplicate this real quick. Okay. Oops. So first thing I'm going to do, if you guys all have the Arduino IDE installed. Anyone not have the Arduino IDE installed? All right, cool. So I'm gonna use Sketch real quick. For the Arduino you guys will be using, we'll need to do some configuration before, because even though I flashed it with a new firmware for using the Arduino IDE, you do have to do some quick steps. So open up your file, preferences, and on additional boards manager, I'm going to show you guys the, yeah. I'm gonna post it on the Discord for Hyperloop so you guys can all use that in general. So copy and paste this link and put it into the preferences over here. Let me know if you guys all did that. So let's go to file preferences. And then in this right here, just paste the whole link that I gave you guys on the Hyperloop. That way you're basically adding this board to your to be able to be used with the Arduino IDE, because it's not originally supported by it. When you guys did that, you can plug in your board to your computer. So I'm gonna plug in mine. And then you wanna come up and do it here. Like if you wanna, because this is our lab, so.
Okay.
Yeah, I'll just tell you what to do and you can make it. Okay. So are we all here? So I'll paste it, it's all good? Yes? Yeah, thumbs up. Okay. So after this, you're gonna go. First of all, is your guys' ID like this or similar? Is it the old one or the new one? I have the new one. So is it all like this? Okay. So I'm gonna select board. Select other board report. Make your COM port for it, and for your board, you'll search up the 328 PB, 328 PB, and I believe it should be this one. If it's not this one, it's probably this one. Let me know, because I do have a different one also installed in it. So there's like 2 different versions I have. So sometimes I forget which one's which. I believe it's this one right here though. Can you guys confirm? So we went to board manager here. Select other board and port. We chose the COM port, and we went and chose the 7328. And it should be, it's probably only 1 or 2 options, not 3 options. So let me turn off my a little bit. Wow. Okay, with UMC.
Yes, you have
Type B,
yeah,
no,
no, BC.
no. It's like on your own, that one. I'm sorry. What do you guys see? Yeah, here's the older one. The new one, do you see this? 7328 PB, 0328. Yeah, yes. Okay, just go to the top of the first one. It's okay. Yeah. You should press yes. We'll install all the stuff. You see, plug it in. Yeah, the you press yes, yes. That's okay. Press yes. Yeah. With your board, and then you go down to your work. You go to work yet? So, not very hold it. You go to tools. You put the link yet already? Yeah. Alright, then go to Word, find the so go to Word, scroll down to the maybe is that it? Go to the Word line, and then that. Yeah. Alright, is it good?
Go ahead and install it.
Yeah. Yeah, but it's fine. Maybe, you never know. Alright, are you good? You get it installed? Okay. Oh, that's very good to go.
No, I copied that.
Oh. Oh. It's exciting. Oh. Okay. All right. Are you feeling today good? They're working.
If I saw the right, so I put the link in, but then all those steps we did, should still work, right?
That can still charge like one time. So uninstall, well, uninstall now, go down. Down slash, hold on. So was that, didn't show? Yeah, install that one. Okay, and then go to install project, and go to source, go to board, and then demo, there you go. Okay, so now I should be able to do that, okay. You press OK on that one, you press OK on it, so I'll just tell you what to do. Okay. So press OK, so, wait.
Oh, wait, which
So click on the top one,
top?
right here, on this one too, click on it, yeah, now press OK. So make sure your port is correct also, so the tool, if you have the other old one, tools, port, change your port. If not, just, if you have the new one, just click up there and choose your correct port as well. And then we turn it's there. So first thing we'll do will be a very, very simple thing. Okay. What we'll do is we'll blink the LED that's already blinking on your Arduino. Make it move faster. Okay. So the first thing we'll do is in your setup. So yeah, go to line 3. Press tab. So we're gonna end it properly, yeah. So let's first do simple. So let's change the input of the pin 13 to be an output. So do you guys remember how to change the pin mode of a pin? Or the mode of a pin? I didn't give you the answer.
No.
Okay, it's the pin mode function. So we'll type in pin mode with a capital M. So lowercase pin, capital MOD, parentheses, and then we'll type in 13, comma, caps lock high, type in high,
Wait, like
H-I-G-H, high, not high. And then semicolon at the very end. So as the semicolon will basically tell the, not there, at the end of the parentheses, so backspace, and go all the way to the end, yeah. So that tells the compiler, so the thing that interprets your code and changes into the code for the Arduino, that is the end of the statement. So this allows you to actually put everything on one single line and upload it, and it'll work. But I don't invite you to do that. Don't do that. Please don't do that. Okay. So we just changed the pin mode of the LED to be high, right? So wait. I'm sorry. It's not really high to the output.
oh,
High is the digital write or the writing to the LED.
this is so okay.
So it's all caps still.
Okay.
Type in output. All right. So before the void loops, this for this case, actually, let's go to line 1 on the very start of line 1 and enter. So go to line 1 again. We'll name our variable, let's say time. So is time what for us and on the Arduino works in milliseconds, right? So it's gonna be in an integer. So we're gonna use int. So I don't know. We didn't go over data types, but does anyone know what int is?
It's like
Yeah, an integer. It's an integer. So it has a certain limit of 32,000 something. I forget what it was. 30 million, but so I just put int and t space. Now we'll do time or ti, or we'll not do time, but we'll do time with 2 e's because time itself might be a function of their limit.
okay.
So or just put t1 is good too, yeah. And set it equal to, so space equal to space, and then we'll do how long do we want the LED to stay on? How many seconds?
4
4 seconds. Okay, yeah. 4 seconds, 2 seconds,
to
2, 4, 2, 3, 2.5.
does 3.
3. Okay, 3. So we'll
3.
put it for 3,000 because it works in milliseconds, right?
Okay.
And then semicolon. So on the same line, you can press two slashes, so two slashes, and that's your comment. So you can tell it, okay, time is actually in milliseconds here, so I put 3,000. So you can write whatever you want, if you want to write the code to tell it, or write basically a comment to tell you what your code is going to do. That way you kind of keep track of, and you can tell people what your code is doing. You don't have to be too, yeah. A little early, huh? Okay. So now press enter. Your computer. Computer. Or yeah. All right. So now we'll do int of time 2. The T2 is equal to yeah. So do we want to? How long do we want the LED to be off? You know, same as T1, we can do something completely different. So it turns off for a while, it turns off for a short bit, or anything else. Like, what do I want to do?
Half a second. Half a second.
Half a second? Okay, so 500.
500.
So put 500. And then semicolon. If you want to comment your code again, you can do that. If not, it's okay. All right. So let's go down to the void loop. So line 10 in our case. And press tab. All right. So our first thing is going to be turning on the LED, right? So we'll use digital write, right? Or do we use analog write? What are we using? Or analog read, or digital read, or pin mode? What are we using?
To turn it on.
Yeah.
Shoot, wait.
Anyone? Digital what? Read, write, what are you doing?
Digital write.
Digital write, yeah.
Digital write.
So we're gonna write it, so digital write. So capital W.
Oh.
Capital W, yes. And then we're gonna parentheses at the very end.
Oh.
Yeah.
Parentheses.
And then the 13, comma, and we'll do high, capital, in all caps, high, for 5 volts. And semicolon
Oh, at the end.
at the very end, yes. And then press enter. So now we're going to wait, right? So your delay, that's to do your delay. So delay,
Delay.
and then parentheses, and then go to T1,
T.
and then semicolon at the very end. And then enter. And now set it to low, so you know the drill, I hope.
Digital write.
Yep, and then put in your parameters.
Is it still 13, but like low?
Yep,
Yeah, that should be.
and then semicolon, and then enter, and then you gotta delete again. So you gotta turn it off for a bit, right?
Yeah. T2.
Yep, and then semicolon. And now press the right arrow. You see the top left corner? So the right arrow?
Top.
Left corner. Yeah, click on it. All right, we'll see if it's an error or not. All right, is it uploading? All right,
There is it.
failed.
Yep.
Signature, double check. Yep. Oh man. Oh no.
What?
So this means that 58. So let me know if anyone else has the same problem. Let me know. I hope no one else is having the same problem. Please. Alright. This be this one here. Actually, it's the wrong one. So this should be right now. There we go. So now you'll see it on for 3 seconds and short blink, right? Does everyone have that? All right, you're gonna have to do some quick changes for your thing. So you're gonna have to first go to the Hyperloop Discord and copy the links that I sent you and then post it in the go to tool or go to preferences and go down to the Word URL and then paste it there. So does everyone have it? Is everyone blinking like it should? On for 3 seconds, off for half a second. Or are we still waiting? Huh? They're working.
Oh, yeah, I just adjusted some.
Wow, you're so cool. Okay. All right. How you doing? Bro, okay. Anyways, anyone need help? Are we good? Okay. Yes, sir. Digital, what does it say? So you capital, what, capital the pin, so it's pin with capital M, and then
Oh.
ODE normal.
Oh, okay.
Yeah. You want me to increase the text size?
Yeah.
All right, I'll do that real quick. Okay.
I think I just heard it wrong. I think the MOD all that.
Well, I bet say capital M O D E. I guess I kind of missed that one up. But here you go. Actually, can I just fix that without the entire thing? Uh-huh. We'll do 20. And then we'll do bigger. All right, can you, is this good or is it too small still? I think it might be the same thing. All right, is this big? Is it good enough? Is it big enough? Can everyone see it? Is it big? Is it good? Is it good? All right, cool. All right, that was pretty simple. How do you guys feel about it? Yeah?
Yep.
Okay. All right, so let's do some reading. So get your kits. You wanna get your kit?
Yeah.
So. Yeah, you can use. Oh, line of cable, but you can use like an area.
I got you.
All right. All right, I'm gonna go look at the. Are you copy the link? File? Preference? And you see the original board manager, right? Yeah, click on that, then you come over there. That's not. That's not really bad. You must have picked it. No, it's the leak, the leak. No, the leak, don't click it, copy the. Copy the, you can copy there. Yeah. And then paste it there. There you go. That's okay. That's it. Now, go to, now plug in your board. That's your board button. Yeah. Click on the board. Okay, yep, add that. But, you know you have to, bro, okay. Alright, so, let's go through this kit now, right? Everyone has a kit? I hope. Okay. So let's get your breadboard out. Right? Get your breadboard out. Yeah, you have two breadboards in the side. Yeah. So we're gonna do a simple reading, right? And a simple writing. So if you guys remember for the circuit construction workshop, you can dim an LED, right? Just by clicking an LED to a potentiometer. We'll do this to code. All right. So everyone in the blue bag, get out a potentiometer, the blue circle, with the pins on it. And then get out your resistor. We're going to use the 220 ohm resistor. Or the 230, you'll use 230 ohm. And then you need wires, so make sure you guys have the wires, the wires. Yeah, and then that should be it, I believe. Oh, get an LED out too. Get an LED. So we'll do different things. It's in a bag full of terminal and it's all blue bag. there are terminals and potentiometers in it, so.
Which one's the?
Potentiometer is this one here, the circle with 3 pins on the bottom. Yeah.
Oh, this one?
Yep. And then get a 330 ohm resistor or 1K ohm too. Let's see, which should we use? What kind of ones are there? Let's use 330 ohm resistor. So in the resistor bag, look for a 330 ohm resistor. Say one of the yellow 330 says on it. Probably yellow 330.
Oh, yeah, I think it's, yeah, there we go.
Yeah, look at the 330. So let's get a resistor out. Get some wires. Alright, what we're gonna do. Let me get the expo marker. Where'd it go? There it is. Okay. So let me erase this. I'm on this side so you guys can see better. I have to write better. So we're gonna have, so whatever's over here and pins over here, right? We're gonna make a simple circuit on your breadboard. That's gonna be, you're gonna have your potentiometer. So this is your potentiometer. That's how they show in schematics. Right? That's your potentiometer, the 3 pins. And then you have your LED, so that's gonna be your LED. And then you have your resistor. That's gonna be your LED. Right? So we're gonna put LED, we're gonna put the 220 ohm resistor probably right here. Or be 230 ohm. And what we'll do is you'll have your plus 5 volt, right? One of the pins. Your ground, your 0 volts, right? Going to the other is ground. And then this pin right here, of the potentiometer, your middle pin, will be your data pin. Over here from here. And then what we'll do from here, we're gonna bring this out to, let's say, we're gonna put this, we're gonna input this pin to, let's say, pin 4, or pin A0. All right, that's gonna go into pin A0 of your Arduino. That's your analog reading pin, right? And then right here, we're gonna put this to ground, and you're gonna output from, actually, you're gonna get a pin going. This is gonna be, let's say, I believe pin 6 to the field on pin. So it was pin 6. Let me make sure. Off the top of my head. Let's see. So let me show this on the actual chat here, or the screen here. If you want to ever have doubts on schematics, right, on which pin's which, you can always just open up your browser. So for this one here, it's called the Atmel Advika 328 Explain Mini. That's the full name. You just type in 328 PB Explain Mini, right? And then you type in pinout. And you'll get a nice picture of all of the pins and what they do. But a simple solution for me, because these boards are similar to the Arduino Uno, just look at the Arduino Uno spec, right? It's a lot nicer to look at. So Uno R3 pinout. And you look it up, you get something a lot nicer to look at, which is like this. Oops. And so here you go. So it looks like pin 6 is a PWM pin, so we can output that to the LEDs, right? So let's first create these 2 circuits on your breadboard, right? It's very simple. So put your resistor into your LED, put your ground, put your potentiometer, power, and ground, and it's the wire. Right? So let's do that. Now, does it make sense? Okay. I will use, I can, do you want me to build it right now? want me to build it for you for the first one?
Sure, yeah.
Okay. So I'll put it on the screen as well. So it's easier to see. So we will, let's go to Zoom. Where's Zoom go? Okay. Which one is this one? That is this one. Okay. Have full screen. I'll solo share for now. That is blurry. Oop. I'll turn the light on. Whoa, that's for an That was mild, minor, oh. Let me see if this will fix it. What is going on? I think it got messed up after the other. Okay. In that case,
Oh my gosh.
it's actually bad. Maybe
Yeah,
it's just
pretty-
like, wow.
Is it autofocus? Is it manual?
It's I know why, because the Zoom background was on. Oops. That's better. All right. That took a bit. Sorry, guys. All right, so let's build this quick and simple circuit. Thank you. So, like I said, let's first get your potentiometer, right? Let me see if this one has a nice. Do you see the 3 pins? Yeah? You see like me at an angle? Can I show you? You can see it there, right? The 3 pins. So your middle pin right here is gonna be your output, your signal wire, okay? And these two, you can go either way. These two will change the way your how you spin it. So doing, let's say, if you're looking at like this way, right? Doing 5 volts here and ground here, I believe you can spin it this way and it will increase the volume or lower the voltage. Or the higher, there is a lower the resistance. If you go the opposite way, it'll change it, right? So we'll put that, let's say, on numbers 28 to 30 on this side right here. Just like that. So you have 28, 29, and 30 as your pins for your potentiometer. Okay. And then on the other side, we're gonna do is we're gonna put the ground of the resistor to, yeah, so let's say number 1, I1 on your breadboard, like that. Kind of hard to see, so I'm gonna say I'm gonna call out the coordinates right now. Okay, so the resistor goes from the ground to J1, sorry, and then your LED, your positive node will go to E1, and your negative node will go to F1. Right, so it kind of transfers that. So now you have your LED like this. Okay, and then you're gonna get your wires. So you're gonna get a bunch of male-to-male wires right here. And then if you want to do this, what we'll do is we're gonna plug in your positive. So let me put this right here so I can use this reference. All right. So you're gonna do is, if you see how this is currently made, well, it's kind of split for you guys, but the LED is right now going to the ground, right? So you have to power the LED with the 5 volt or not 5 volts, but the output pin of the Arduino. The Arduino can support 1 LED or 3 LEDs before it needs the external power source, right? Per pin. So, but the potentiometer here, you gotta put your positive and negative still. So we'll do that first. So get one of the wires. Let's say blue, you got blue right now?
Yeah.
So the ground first. So put in the minus on the bus.
Anywhere?
Yeah.
Good.
And then put up to pin 30. I believe it's anywhere on that 30. So that's already there. So put in the minus bus now.
Got you.
So, all right. So you have wire here at 30. And let me see if I can make this better. That's the wrong mouse. All right, let's see if we can lower the brightness and then zoom it in so you can kind of see it better. It's kind of grainy, but is this a little bit easier to see? little bit or no? Should I increase this, increase the contrast? Is that easier to see? Is that better or no? It's a little too saturated. All right, anyways, I'm gonna. Yes, this is the best I could do for now. Yeah. So you got your ground of the bus to the pin 30 or on the row 30, okay? And then we'll do, say, a red wire. That'll be a positive, so put that on pin 28. And the positive bus, or the plus. So this won't work because the breadboard only goes up to here. So all these are kind of but not across this one. So you have to do it on the other side, right here. Okay,
Oh,
yeah, so that'll be positive there.
you said that wouldn't work because of.
So in the bottom of this row, I would can't tell right now, but if you look at it. Okay, but basically these rails are kind of like along the entire axis, right?
Mhm.
So this is all put together.
Yeah.
But this way it doesn't, it's only till these 5 pins, and then you gotta go over, or 6 pins, 5 pins. Yeah. So only these are connected here, and you separate.
Oh, okay.
Because that way you can put stuff like the button, the switch, or like an IC or something else on there.
Oh, gosh.
Okay. So now we'll get another wire. We'll connect the 2 ground buses together. So I'm gonna use black in this case. I'll just connect this bus line over here to that black bus line, the negative bus line over there. That way we just have all the negative grounds connected together. All right. So I'll just be in the corner somewhere. But it is ground to ground. I don't know why it's okay. It is ground to ground, okay? And now we'll go to the Arduino. So on the Arduino, I'll look at this. All right, I'm up on the floor. So you'll have, if it's like the Uno, you'll have your digital pins on this side, your analog pins on this side, right? So A0 is this header right here at the at the seam. You see there's 2 different header pins on the side. So that bottom one is, I believe, pin FPC0 is labeled PC0. That is A0. That will be your analog reading pin from the potentiometer. All right. And then on the other side, number 6 should be PC or PD6. All right. So let's get the wires. So we'll get, let's say, a yellow wire, a signal wire from the potentiometer. That'll be your middle pin of the potentiometer. We'll put that one to pin PC0. And then we'll get another wire. Let's say I'll use white in this case. I'll use red because it'll power the LED. And we'll go to PD6. And then we're gonna put that in the, let's say, pin B1 in this case. So we'll probably swap it over. All right. So now you have them like this. So you have pin PD0 for your analog, A0. And then you have pin PC6, PB6, sorry, PC0. PC0 for analog, A0, and PB6 for your pin 6. All right. And then we gotta put your positive and negative. So get a wire and put it into the 5-volt line. That's over here. It should say 5 volts on it. So put that one and put a positive bus line. Let's say 5V on it.
Oh, got it.
You might want to put it on your Arduino over there.
What was it?
Actually, no, over there. Yeah.
Okay.
Fine.
Actually, what's that for? Oh, this one. Yeah, this one over.
Actually, you know what I can do is you take your kit, I'll build one over here, you build one over
Okay,
there.
okay, that's probably better idea.
Yeah, so just take, you have your Arduino over there, I'll save some from here.
Okay.
And that way, just take your wires and plug them in. So I'll build one, so here's your kit. So let's leave it here.
Yeah.
Yeah. You want me to put it over there or over there?
Oh, yeah, I'll just go back.
There you go. Yeah. Okay. Alright, let me rebuild it on this side so it's easier to see. Alright, so I'm gonna remake it again, so you guys can see better. We're gonna get our here, breadboard here. So we're gonna get our potentiometer. We're gonna put it on into 38 on E. Let's see. Yeah, E and D. So we have E28, D29, and E30. You have your resistor here. Your 330 ohm resistor on the side. Over. That's not it. Right. We're gonna take out one resistor. And we're gonna put that one negative here. Actually, I'm gonna try to save wires in this case, and I'm just gonna put it over here. Or turn it on. Okay. So I believe J1. Okay. And then thanks. And then we're gonna get an LED. We're gonna put it here to but the positive pin here goes to E1, negative pin goes to F1. And then you have your wires. So we'll do. So the positive of the potentiometer here is on 28. So the 28 on A28, and we're gonna put that in the positive. We're gonna do 30, 20, 830, and we're gonna put that on negative, the negative bus line. And then we're gonna use the signal wire here in the middle. We're gonna use that for the signal to send to the Arduino. And then for the we're gonna put the negative here to the other negative over there. So that way we make sure all the grounds are grounded. And then finally, we're gonna put, let's say, a wire from the positive lead of the LED, let's say A1. And we're gonna connect these. So A1 here, the LED goes to PD6. So that is right here. We'll have the yellow wire from the potentiometer go to PC0, which is over here. We're gonna go use the 5-volt line of the Arduino. So 5-volt is right over here. I'm planted the red.
Am I using this Uno or?
Yeah, that's yours. Yeah. And then finally, we're gonna use the negative line. I'm gonna use the one over on this side. It's this ground right here. So I'm just gonna use that one. So that's a ref, that is ground. That's the second pin on top, and use that as negative over there. If you look carefully at the top few pins of the Arduino that you guys have, you'll see that the bus line kind of gets shifted up or down on the labels. So make sure you be aware of that. So if there's PC5 and PC4 are actually the top two pins, and there's no headers there. So the headers are only on area ref and ground, which are a little shifted down by one pin. So make sure you guys know, like, be careful about that. Anyways, once you've ground and powered everything, this should theoretically work. So send your code over to your Arduino, upload it, and then see if you can dim and undim, or actually, didn't put it yet. I probably didn't have it coded yet. We just do sorry. All right. Once you have it here, however, let's code it now. So let me know when everyone's over here and everyone has done the circuit stuff.
We can unplug this.
Hmm?
Can I unplug it?
Yeah, you can plug it. You should probably unplug it before you change the circuit.
Gotcha.
You should unplug your circuits. For our low level stuff, it should be fine, but still, just always be careful. So once everyone's over here, let me know. Did you do the thing for your board? You do the thing, bro. Your life. You do that?
I put my password in the wrong.
Okay, well, it works now. Okay. All right, is everyone here? Yeah, can we move on? All right.
Yeah, I'm still
Oh, okay.
Yeah.
We'll do that.
kind of face that when you're going over the wires and shoot.
Okay. I'm gonna lower this so you guys can see better.
Okay.
I mean, no, this also helps. Just too close.
That's a little bit. Yeah.
So we'll zoom it out now, and then hopefully it'll look better.
I should also work this.
Let me first put this up real quick, and then I'll have you. All right. Yeah.
These two wires. This one.
So this one right here, if I turn this around, it'll be better to see. Does this make more sense?
That's
So your signal wire from your potentiometer goes to the PC0, right? And then your wire for your LED, which is mine right here, goes to PD6.
okay.
Okay. So for everyone else, let's start programming this. So open up your Arduino IDE. And okay, well, since you guys know how to set the pin modes and writing, let's do the starting, right? So our function here is to change the brightness of the LED with the PWM pin, right? So what's our first step? What's our very first step to programming this function for the Arduino? Before that, you should have your variables in mind, right? So let's first set up our variables or our definitions for our pins. For this one, we're gonna actually name our pins, okay? So we're gonna use hashtag define on the very start. I'll put it up right after. No plugging yet. We're gonna, yeah.
Oh no.
Okay, we're good?
Yeah.
Let's start programming then. So let me start sharing a screen. And then, oh, that's not. Then let's go here. So I'm just gonna delete the old code. And then, oops. And then here. So up here in line 1, we're gonna do, I'm gonna turn off the light again. On line 1, we already define our variable names, right? Or our pin names in this case. So we'll use hashtag define. So I'll put the hashtag define. And that will be for, you'll use that a lot more for pin names, and that's probably it. sometimes for parameters, but not really. So press space. So we're gonna hashtag define, we're gonna put, what should our pin name be? LED pin? So LED pin, yeah. So in programming, you'd want to use some kind of like convention, like upper camel case or lower camel case, which just means the lower camel case is what I use a lot, which is the first letter is lowercase, the second letter or the first letter of the second word is uppercase. So I use LED space then capital P I M. It's just like better convention to have some kind of standard to follow when you're writing code like this. So yeah, we'll do that. So you'll see that a lot in the functions like, digital write, pin mode, like the first letter of the second word is always capital. So that's lower camel case. So press space. So our pin in this case is going to be pin 6. So press 6 and press enter. No semicolon is needed for the defined statements. Okay. So let's make our definition for our potentiometer. So again, after define. And then let's say pot pin or pot.
Pot.
Yeah.
Oh.
So like for potentiometer, right?
Yeah.
Space. And we'll make that pin A0. So it's capital A for A0 because that's the labeling thing, yeah. And then press enter. Okay. So now let's make our variable for the brightness, right? Is our brightness going to be an integer, a decimal, a boolean? What is it going to be? What's our data type going to be for our brightness variable? An integer, a decimal, or a boolean?
Decimal.
An integer. So remember, the PWM pin we're going to use for this can only output basically a value from 0 to 255, right? So we'll do integer, so int, int. We'll make it, they'll say it's bright or Brit. What are we going to name it? I like my short names for my variables, so I just do that. So, and it's set it equal to, and we're gonna, let's say, you don't really have a default, well, our default value should be 127 or half brightness, right? And that way we kind of use that very nice. So 127, and it's not at volume. So now we just basically define our names for our pins. So you use that in our code later on, and we made the variable for the brightness. All right. So let's go to our setup function.
Oh.
All right, press tab. Just follow, yeah. So you guys are masters now, right? At the how to change the mode of the pins. So let's change the mode of the pin of LED pin. So what do we do? What do we do? Pin mode? Pin mode. Let's use pin mode. The capital M, yeah. And then parentheses. Now let's use the name of the LEDs, of the pin. So use LED pin in this case. Just type in LED pin and comma. And then our LED pin is an output. So type in caps lock output. And then semicolon, and then enter. So now let's change the mode of the pin of the potentiometer. I'm not going to help you this time, so figure out how do we do it. Remember, the potentiometer is an input. So what do we do? That's the LED pin. Ready, potentiometer now.
Oh, got it. Oh, there you go. Pot. Input.
Yep. All right, and then end the statement. And then enter. All right. And now, let's see, we got our inputs, or we got set our values. And let's go to our loop actually. And then let's do Brit. So what we're gonna do is, before we start, actually, don't do that. Yeah. So what we're gonna do is we're gonna get the value of the potentiometer, store it into the Brit variable that we made. And then we're gonna use that variable to actually write out what we want, right? So in this case, we're gonna use Brit, so BRIT lowercase, is equal to. So how do we read an analog signal? Oh. No? Analog read. Almost like they made it so it's easy to see. Okay, so use analog read. Okay, yeah, there we go. And then parentheses. And then what pen we're gonna use? We're gonna use the pot pen, so pot.
Yeah.
And then semicolon. And then enter. All right, so now we have the variable with us, right? But remember, this value goes from 0 to 1023. Our value you want is from 0 to 255. What do we do to convert from 0 to 1023 to 0 to 255? Map. Let's map the value. So we'll do Brit, because you're going to use the same variable. We're just going to overwrite the value with the new value. By doing Brit is equal to map, parentheses, open parentheses. Okay, we're going to put Brit back in there, comma, 0, comma, 1023. So 1023, comma, 0, comma, 255. And semicolon. So can you guys tell me what this one statement is doing? In detail, what is the statement doing? Step by step. Yeah, but can you tell me why I'm using Brit is equal to Brit in this case?
You're getting that original value,
Uh-huh,
and
so it's over here.
then you're putting it back in that same value,
Uh-huh,
and then you're changing it to the value.
yeah. Since in our case, we don't need to save the original value per se, we're gonna immediately discard it anyways. So what we'll do is we're gonna use that storage area. When we read it, we're just gonna put it back in, remap it, spit it back out, and I want to use it in our LED. So now let's do, so how do we send a fake analog signal to the LED? How do we write an analog signal to the LED?
This statement?
No, what were you saying?
What was it? Analog read or?
That's, we already use analog.
Oh wait, no, it's
Analog write? That's crazy, guys. Analog write, that's a great idea. Let's do
oh
that.
shoot, okay.
So let's do analog write. Parentheses. And then you have your pin. So we have our LED pin over there.
Thing,
The LED pin.
oh, LED, oh, no.
Yeah. And then comma, and then the value. So our value is Brit. So let's use Brit and then semicolon. So what we just did, we'll go over again. We first declared our variable names for our pins, right? And we set up to the pin numbers. Then we went and made our brightness parameter, right? You can even take out the 127 equal sign, right? We just put int Brit semicolon, because you're gonna define it later on anyways. But for our case, we just default in case. And then we set our pin modes, and now we're gonna write it with our new value, new map. So let's send it over to the Arduino. So send it over by plugging our Arduino in first, yeah. plug your Arduino in, send it over. If my wiring is correct, then everything else is good, it should work. If it's not, oh well, we can fix that. So, plug it in. Then send it over. Do we have an error? Thank God we don't. Okay. So let's look at our LED.
It's not on.
It is not on. Let's turn this over and see if we can get this on. We do not have it on. Okay. Well,
Maybe there's a one issue.
probably wire issues.
I thought he was saying like, oh, I'll put it up.
You want to double check?
Yeah. Well, let's go and I'm going to use yours for the debugging. All right. So we have. It could be also that this is the wrong pin number. Because then it's a little hard to see the pins. Is it working? Anyone? No.
Yeah.
It's working? So it's probably. Let me see. Let me make sure. Can you turn it? It'll move. Do it. Yeah, okay. That one works.
I'll check the wiring.
Also, it might be a dead LED, so if you want to check first to the LED, change the orientation, make sure your orientation is right. Is it working? Yeah, the PC0. Yeah. It's working for you? Nice. Okay, let's get that. You didn't have the code yet. You're supposed to upload it. Yeah. Alright, is it good?
Oh.
No, we're good to go?
I was like verified.
No.
Alright, let's look at this. Right? So we have PC0 here, we have the ground, we have power, the left is good. You have this is power, actual power. You don't have a ground. You do not have a ground. You cannot ground it. You get another wire? Yeah, so let's make sure that our pieces are grounded.
Whatever you just turn.
You have my LED, by the way?
Yeah.
Alright, so is it the right orientation? I believe so. Alright, so we're gonna put it right here, and this should work. So now to rotate this, and you have your dimming. So we just basically recreated what the potentiometer can do on its own, right? By itself, it's a resistor that's variable, so you can rotate the potentiometer by itself and it'll do the same exact thing. But now that you have an input of a various input that you can change, you can use this to, let's say, change the position of a servo motor. That we don't have. What we can do is change how fast the LED can blink. Right? So let's do that. So now Brit can stay as Brit, right? First of all, what's our range gonna be for our blinking? What's the fastest we want it to blink and what's the slowest we want it to blink? As in the delay. How fast do you want to delay? That's a 1 second delay.
Oh.
Per on and off.
Like-
That's gonna be a 2 second full cycle. So what's our fastest cycle gonna be?
0.2 seconds?
Huh?
Like, I don't know, half a second?
Half a second to 500. So our total time for on and off is 500 seconds or 500 milliseconds, or just on is 500 milliseconds. Off is 500.
We could probably do total 500.
All right, yeah, I'm good with that. All right, so our lowest is going to be 250 then.
250.
So let's change our Brit, right? So we'll keep do you want to keep the name the same as Brit, or do you want to change the name? Because in this case, it's not Brit anymore. It's going to be how fast it's going to change. All right, let's say it's pulse, guys. Okay, POL, POL. Don't change it. Yeah, let's do a POL. And then go down here and change all the Brits to POL. You don't have to worry about that one. But these two you have to worry about. So 13 and 14, line 13. And then we can actually delete line 15 right now. So just delete the line for now. So if you look at us carefully at the map function, you'll see that this is your input range. This is your output range. All right. So since our fastest delay is going to be 250, we're going to put this 0 right here on the fourth one is 250 now. So that 0, not 255, so 0 before that one is going to be 250. What's our slowest total time going to take? 5 seconds? Oh, yeah, no. Okay, so we'll change 255 to 2500. 2500, right? Okay, so let's talk about function. How to create your own function, right? So let's go underneath the void loop. So line 17. Let's enter again. This is how the extra space. Okay, so line 18, right? We'll type in void space. Let's call it blink LED. So blink and then so this is blink LED. So we can type the same way. Yeah, LED, all caps LED. Yeah. And then put a parentheses. All right. And then inside of the parentheses, let's look at a parameter, our delay parameter, right? So type in int and let's say space, space, and let's say try just T for now. Yeah, T. And then I'll go on the very end and press enter, so new line break. And then open bracket. So open the bracket, the curly brace, open curly brace, and enter. So now you already pre-indented, right? So you're over here at line 20. So now we'll do our function for LED. So we'll do digital write. So let's digital write. And then let's do our LED pen. I need to move that back off.
Oh, yeah, that's good.
So LED pen, your LED pen. And then comma, that's the high. Then semicolon. And then, enter delay. And you're gonna put parentheses T in this case. And then enter, semicolon, enter. Then, turning it off, so the drill. You put FL, so the AL, so watch out.
Oh, I cannot type. My bad.
That is big enough.
Yeah. Okay.
And then, yep. And then delay again, so delay and then T delay. And then semicolon. Right, so in C, when you define a function, you got to initialize it on top. Or initially you got to declare it, I forget. Anyway, scroll all the way to the top. All right, before the set. So, right, so don't delete anything. So go to line 2 or line 3, go to the end of line 3, press enter twice, 3 times. There you go. Line 5. Go to line 5. So we'll type in void. And then we'll type in our function again. So space, our function, what's our function? Blink LED. LED, yeah. And then parentheses, int. And then no thing, that's it. And then semicolon. No names. Yeah.
Gotcha.
So this basically declares your function. Right? It tells it, okay, it's a function. It's gonna be having an input, a parameter of int. You don't have to do this for Arduino, but for C++, you have to do this just to declare a function. So it's like good practice sometimes just to have this in your code. It won't change anything, it won't do anything like bad, it'll just, it is there. So this is a good practice to do that. So scroll all the way down again. So back to our loop function now. So we have this, we have our function. Let's go to a loop. And the tab. So now we'll do a blink LED. And then parentheses pulse, or pulse.
Oh, I can. How about?
Pulse.
Oh,
And what happens. And then change your potentiometer and reading and see what happens. Right here, just changes.
Oh, just change that.
Yeah, because this is all code. So you go this way, it goes really slow.
Oh,
And then you go this way, it'll go. Yes. It goes so fast you can't. There you go. So if you time it, it should be about the time that we put it past. So we did it from half a second to 5 seconds. So you're working to one side, it should take about half a second for a full on and off. And the other side should be like 5 seconds for on and off. So do you guys see how you can use this to like do a lot of different things? It's just a simple volume knob, but it's not a volume knob anymore. I'll change the, so you can actually pair this up together with the brightness, right? You can map this to this, blink it at that, but then analog write it at like a different map value. And then now I change both the, or you change one variable, you can change the brightness and the delay. There, you know how you do that? Okay. Let's see, what else do we have in this amazing thing? We have tag switches. Look at that. So these are very similar to like slide switches or any other switches, right? They'll input a 1 or a 0. That's it. It's very simple. The way that they work is a little different though. So what will happen is you go over here. Like this. This is your button, right? And you'll have these 4 little prongs on the corner, on 2 sides, right? Inside, they're basically like kind of like this, where your button's like right here, so that when you input, let's say, 5 volts in here, it will go directly out this way. But if you press the button, then it will go out this way. Does that make sense? Basically, across, right on top of each other, they're connected together. But this way they're not. Well, these two are connected together. So if you put one pin on the bottom, the top pin also will be the same as the bottom pin, but across from it, those two will not be on the button. Does that make sense? It's a little confusing, but so what you can do now is you can do conditionals. So let's use one of these light switches. So there should be one of these light switches in your bag, as well as a tag switch here too. Right? So these 4-prong ones and these 3-prong ones. So let's get those out of your bag. And I'm going to bring back the camera so you can see what I'm doing. Nice, very, very good. Yeah. Sorry. We're awake now. All right. So let's do a. So where did my LED go?
I gave it to you.
Uh-oh.
Is it right there?
Oh, there, I can see it. That way I'll just put it in here so I guys have the same hook as you guys. All right. So we're here in our current state. All right. Now what we'll do is the first thing we're going to do is basically change the function of the potentiometer, changing between brightness and how fast it blinks. All right. So we have a slide switch, which is pretty easy to use because it toggles by itself. So you can go either way and do it. Or we use a button and we have to get the code for it to toggle. What do you want to do? The easy one or the hard one? Or medium one, not hard. What are you feeling? Both? All right, we'll do the hard one first. Okay. So for this one, we could possibly need more wires. So let's see how that goes. We're gonna put the switch right in the center, right here. All right. Oh, let's see. right there. So that way you have all 4 different parts. What I'm gonna do, just to make this a bit easier, is I'm going to, let's see, I only have 2. Does everyone only have like 3 more wires left? All right, okay, I'll use that. Okay, so we're gonna do is we're going to use the input function this time around. So we'll put ground on. So my button right now is on numbers 19 through 21. So are you guys button is also 19 to 21? Yeah. So I'm gonna make the ground pin on pin, let's say G21 is gonna be on the bottom leg, bottom right leg for you guys, top left leg for me. And then, so that means that normally the 0 volt or ground volt will go straight through to the other side of 21, but we're gonna get the input off of 19. So we're gonna get 19. So let's say D19, and we're gonna put that into pin right underneath 6. So PD5. We're gonna use PD5 as our input pin in this case. All right. So she'll something like this. PD5. Are we good? And then what we'll do is, well, we don't have to because we have input the pull-up resistor. So if we're doing it the normal way of using this normal input, we would have to use 5 volts and then put a pull-down resistor for 0 volts. Because what will happen is when there is no voltage going through the button, so the normal way of putting, let's say if we're doing 5 volts instead, so don't do this right now, but if I put 5 volts right now, right? So the button will read 5 volts. When the button's not being pressed, the signal is in the air. We don't know if it's 5 volt, 0 volt in the between the voltage, right? So you'll get some random answer or random like signals. So in order to fix this, we're going to use a grounding resistor called a pull down resistor. We just use like a really high resistor value, like a 10 kilo ohm resistor or a 1 kilo ohm resistor. We put it on the other pin. So for me, it'll be pin 19, but on like G, H, I, J, K side. So that way since this whole thing is like one large line for the button, it'll pull it down first until you press the button. But we're gonna use the ground pin first. We're gonna ground it first. So what will happen is the Arduino itself has a pull up resistor. That way, when we're not pressing the ground with the button, because usually what will happen is then, since there's no grounding on the pin, if there's no pull up resistor, it doesn't know what it is at. Again, it's at random voltage, right? But the Arduino, it has the built-in pull-up resistor to pull the line up. That way, if the button is not being pressed, it is for sure a definite 5 volts. All right. So we're going to use that to our advantage to use less wires and less components. That's all I gotta do for this next one. All right. So let's go back up to our code. The start sharing screen so I can, yeah, I gotta share it. All right, so we're back here again. Okay, so no phones in class, guys. Okay, so what I'll do now with our already current code, we're gonna make a new definition. So on line number, let's say after 2 on number 3, right? Let's make line number 3 down 1. So I like to put all my like the definitions like stacked together. So go to line 3 on the very top, like start of line 3 and press enter at the very start. Yeah. That way the new line 3 is gonna be our new definition. And the hashtag define, let's say, are gonna be our button pin. Name whatever you want. I name it butt because button, but that just means just name whatever. Right. And then name it pin 5 because that's the 5th pin. And name
Wait.
pin 5.
Oh, just pin 5.
Not type in pin 5.
Oh, just 5.
Yeah.
Okay.
Okay.
My fault.
And then, so now I'm doing a new variable, let's take a boolean, right? Because it's gonna be a toggle, high or low, right? So line five. So we'll name it bool, so bool. That will be your true or false, 0 or 1, that kind of stuff. Name it toggle or tog. I use tog a lot, so tog. And set it equal, let's set a point for the arm. No, make it into 0. So yeah, and set a point. That way your default value is 0 for your bool, for your toggle. And then what we're gonna do is we're going to make another input, integer value or another boolean. All right, so so press enter right now. Make another boolean. We'll name it a value, whatever you want to call it. This is the value of the button is what it's going to be. So just make it val set equal to, or you don't set equal to these, but set equal in the val. Yeah, so we'll define that later. And then let's go to pin or line number 13. So make your pin mode for your button to be an input pull up. Make sure you press tab in front of pin. Well, you don't have to, but you should like clean it up so make sure your code is right. So it gets pretty long. It makes it easier to see.
Oh, what was it? Again?
So you gotta make your pin mode of your button to be input pull up. So I'll tell you how to do pull up later, but just type in the, not yet, don't do that yet. Your button name, what's your button name? All right, a comma. And then caps lock. You have an input underscore pull up. Underscore pull up. Not underscore. Pull up. Oh, yeah, there you go. And then semicolon. So this will tell the Arduino to pull it up to 5 volts, so you don't have to worry about the pull up resistor or anything else. All right, let's go to our loop. Let's actually can use one or no, let's see. Yeah, let's go to the blink LED function actually. Now write down the definition itself. So number 25, line 25. Scroll down all the way. All right, so make a new parameter. So it's in T already. So press commas. Yeah. No, not outside, inside the parentheses. Yeah. And then we're gonna name it put int and then space. And let's say so our bread is press B. B. Okay. So now put analog right is a digital right, but analog right.
And
So scroll down to line 27. Where it says digital right.
Yeah.
Come into analog right. To take out the digital part. Make analog. Oh, not really put the equals.
cannot touch to save my life.
Okay, and then type in instead of I, you're gonna put B. So I plus B. And then we can leave it 9.9 as it is. So turn your LED off.
I got you.
All right. So now let's go back up to line 21. So delete that for now. Yeah, we're gonna go back to it later. And then go scroll all the way up to the declaration there. No, line number 7. And in the parentheses, unlike it again. So that way you have 2 parameters now you're inputting, like what it introduces. So now go to line 21. I believe, yeah, line 21. So here, let's do, so we have our toggle and here val. So let's do val. Val is equal to our reading of our button. How do we read our button?
Analog read.
Well, it's not an analog
Oh,
value.
wait, no, digital read.
Digital read, yeah.
Yeah.
So it's a digital read. What's about no closing class? All right.
Oh, there you go.
Now I'll do the pin. So what pin is it? But yeah, semicolon. So now we're gonna talk about conditionals, right? So if we don't write anything down, right? So let's first talk about how the log is gonna be, right? When you press the button, it should change the mode from changing the brightness to change the toggle or the delay and vice versa, right? So we have our toggle value ready, right? So how do we change the toggle value whenever the button is red? So let's first start off, what are we reading, right? The button is sending a ground or a 0. So by default, the Arduino is reading a 1 or a 5 volt, right? And so when you press the button, we're setting the ground, so it'll read 0 volts, right? So how do we use that knowledge to change the toggle? So what we're gonna do is we're gonna use an if else statement in this case. We can use a switch case statement, which is faster, but that's more on another day, maybe later today if we have time. So let's do an if else statement. Your simple if else statement. So if val is equal to 1. So comma. No. Not comma, sorry. I'm in parentheses. Okay. Actually, before we do val equal to 1, so there's many ways of writing conditional or the Boolean statements, right? So val equal to 1 will be if the value is equal to 1, right? Because val equals 1 is assigning the value 1 to the value of the val number. Val equal sign, 2 equal sign is comparing the value, right? But we want to compare 0 because we want it to, when it's 0 is when we do this stuff, right? So we'll do val is equal to 0, right? And space. So that's the first parameter, right? The second parameter we gotta do is figure out the previous value of toggle. So we can either put that in the if statement or we can put it in the actual if statement. So I can either put the conditional statement or the if statement. So put down there. So remove the backspace, the space. Press at the very end, press enter. So you get a new line. Yeah, press open curly brace. Enter. Okay. Now in here we're gonna do tog is equal to exclamation point tog. So let's go. Yeah. So what this SMF1 again. So what this means is set tog to the value that is the opposite of what it used to be. So if tog was 0 and button was pressed, then set it to that's not 0, but that's 1, right? If it's not false, it's true. So we'll set true, and vice versa. So using this logic, you could also just put it up here. Instead of doing val equals 0, you could do if val is not if not val. So that means that if it's not 0, which is 1, because your conditional wants a true. Does that make sense? And this is maybe a little complicated, but it just means because the if statement only runs if the conditional is true, right? And our condition is only true if the value is not true, or not 1, it's 0, which is false. So we switch the value from false to true by using the not symbol. Does that make sense? Or no? It's okay, we don't have to worry about that right now, but that's for later. Right? You good? You good? Okay, cool. So that's our tog statement, right? Our tog. Now press val is 125, line 25, at the end of line 25. Press enter. And let's do the if statement. If. Like here we're going to use that actually. So if tog, right? And then press a curly brace. And so line side, press backspace, press end. So make a new line. So go outside of the parentheses, enter. A bit. And then or the open curly brace. All right. So here. So if tog is true, if tog is 1, let's do what we did up there. Pulse equals map pulse, that whole line. So take line 20 and paste it into line 28. The entire line 20.
Oh, I'm trying to figure it
And just cut it. So, and I control X and I paste it in line 28. Tab and figure line 28. And one more time. Tab. Okay, and delete line 20. Okay, wait, okay, cool. So what we just did was if toggle is true, so if toggle is 1, then it will map the pulse value to the delay, right? And we'll put that as pulse. And then, actually, let's name this T. So let's go on top of void loop on line 16. Yeah. Now type in int, and then just space T, comma, B. Semicolon. So what I just did right there is I declared 2 variables, 2 integers. They don't have a value yet. They will later. Scroll up. Oh, I should, we're not missing anything. Okay, scroll up. So what we're gonna do is scroll up a little bit. So yeah, a bit more. So if tog is true, then we're gonna put t equals to the pulse. Well, that's t. Yeah, type so replace both with t. That single one, yeah. Yeah. Okay, and then put else the else statement. So down here. So right after 28, press enter. Put else. And
Oh my.
enter, open curly brace. Then what I'll do is b is equal to map. So it's just copy and paste the map function.
Map function.
So 27, line 27, just copy and paste it. And we're gonna change some values on it. Okay, so here we'll put b, so press for yeah. So and over here on the time, we're gonna put 0 to 255. 0 and 255. All right, so now I have T and B, and toggle, and that. Scroll all the way up. So I'm gonna make sure that that will be reading. So here our default value should exist. So press on T. So number 16, yeah. So press T equals. And then we'll do we'll think really short, like 127. And then on B equals. So on the comma B equals, yeah, B equals. And then we'll do 127 as well. So when you first shut the code up and you don't press anything and nothing is being changed, or let's see, scroll down. So normally the brightness will be changed to your so your brightness will be changed first. And when you press the button, then the timing will be changed. So when you first boot up your program, in this case, it will blink really rapidly, but you will never get that back afterwards. So now, at the very end of the else statement, so line 32, curly brace, enter. Now let's do a blink LED. And then parentheses, L and T and comma B. And then press enter. So now scroll up to the line, so scroll down, scroll down, okay, stop. So at the end of line 23, press enter. So this normally would work, but the problem here is that a button is very sensitive to presses, right? What will happen right now, if you don't do anything about it, is you press a button, it may or may not react to your press because it's going so fast. Because the processor reads your values too quickly. So we're gonna slow it down a bit. So when you read, right? So every time you read from the button or it's 0, it should delay for a bit. So press delay. We're gonna give it like a 20 millisecond delay for now. Press delay.
So where's the?
Just right here, right there, like me before. Press delay. And then parentheses. And then I'm gonna do 20, and then semicolon. That way, what happens is when it first reads that your button is pressed, it will halt everything for 20 milliseconds, so that in case you're not doing like nothing else is being like read. So that way, no like misfires of like the buttons like waving up and down will be read. Because what will happen is if you try to if you delete that statement, you press it a few times, it may not register your click because it went so fast. It might not register. Okay. And you know what we'll also do is when it's in, let's scroll back up to the pin mode, right? Setup. Let's make a new pin mode now. So 14, number 14. Let's do tab pin mode. Parentheses 13, comma output, all capitals, and semicolon, and scroll down to void loop. Okay, so now go back to the toggle. Is what's going to happen here is right below, right before delay in the toggle. So line 23, at the end of line 23, press enter, make a new line. Do digital write. Comma, or not, sorry, parentheses, not comma. And then do 13, comma, pod, and then semicolon. So what this will do is when toggle is 0, your LED that's already built into your board will be off. When you press the toggle button and it registers that, it'll be 1. That way you know which mode you're on, right? So when toggle equals 1, then you'll be in the timing change, right? If toggle is 0 or LED is off, it'll be in the brightness change. So let's send that over to the Arduino, and if this is correct, we'll see what happens. So send it over. The 13 is going to be an output.
I guess it's out there.
Yes, all capital. So upload your code.
What was for blink LED? What was what were inputting?
So we're inputting both B and T. So let's scroll down. Can you scroll down to your code quickly? Scroll down to blink, the function right here. Here you go.
Sorry, thank you.
In front of upload the code, you upload your code.
I already did.
You did?
Yeah.
Is it working?
So what's supposed to happen?
So right now it's being really fast, right? Yeah. So if you change this over, it should change the brightness of your. Is it dimming out?
Yeah.
Okay. Now press the button. So wait, change it back up. Make your brightness up again. Okay. Now change the button to the button. Do it again. Okay. Do it again. Change the thing. Okay, let's go back to the code. So that's probably happening is up, scroll up to your toggle. Okay. So let's see. We're reading my calendar and the value. Is your button being, is your button?
Check if I clock already. What is it down?
Alright. So you put this in the analog pin. That is the button, right? Yeah. And hold up. You didn't put it on, so you put it right here. Right over here underneath. Right now press the button. And then we'll change it to the penny. Self-axle there. And then we grounded, or that's up. No, okay. Also fix this. That's all right. Alright, let's still move it. So let's see. That's grounded, that's grounded. That's input. We did pin 5. All right, let's see in the code. So in the loop, let's go through the logic. Is anyone's working right now?
I think so.
No?
I think so.
You think so?
I think so. What is this supposed to be?
Maybe press the button. Well, you already faxed, like, display wise. So this changing like wait, I think time right there. This should not change the. Oh, right, oh, no, work. This doesn't work. Yeah, what did you do with that?
Definitely.
Bro, it was scaring me. I was like, who knows? All right, let's see. 5, 6. This one goes to LED. That's great. Oh, this is not even in the. It's
Oh
not
my
in
God.
there, bro. Okay,
My man.
you kind of missed the thing, bro.
Yeah, I can't.
It's okay. Okay, now, there we go.
Nice.
All right, cool. That worked. Thanks. My heart was like, oh my God, I thought.
Yeah,
I
I'm just blind, yeah.
Okay, you didn't want it working? No. And. So that's gonna be your, oh, wait, you have legal right, analog right, legal right below, that's okay, yeah, that's fine. So this right now is toggling or the, write it down. Oh, did you not, okay, E is equal to 55, 3, interesting, yeah, it is working because you see it go now. Right now, in this case, and then you dim it down and hold the button. Yeah, so now you can do is other thing, one in terms of the screen come out.
So it's just gonna be continuous. Oh, so it's continuous with the.
Yeah, oh, we blinking no matter what, but if you change the speed on the rangeometer or change the. But for this one here, whenever you change the state, it'll update the next, thing. Yeah. Now you guys see how you can use now the same button.
There's a building.
But change two different functions on an LED. Pretty cool, right? We can, if you want to do, we can build a binary counter. You gotta build that binary counter. Your question? Or
No.
okay. Okay. All right, this is gonna be cool. Let's do some. Who is Python here? Python? Anyone know Python? Do you guys want to do something with Python and your computer and your Arduino? Or do you want to do Arduino and Arduino communication? What do you feel like doing today? So you have 30 more minutes. So choose, or we all gonna do actually in general. What we're teaching. The floor is open here. Because like this is basically almost all of everything I just showed you guys is going to be used for all different things. Right? You guys get a function today. You guys use digital write, analog read, digital read. You guys use if statements. We haven't used less than, greater than, equal to, but that's all like simple logic stuff. I'm pretty using that in math. So implement that onto here. So is there anything you guys want me to do? Specific, like something advanced, something not as advanced.
Let's say you're giving the negative. My result is someone else's, my budget thing over the line.
Yeah, I can do that one.
Yeah, what did you like say about like the binary counter?
You want to build one? You want to
Yeah.
basically, each time you press the button, you'll increment up our counter, right? And then after you increment a counter, you gotta do with the LEDs, do a binary,
Oh.
counter. That was a painful for me. So I don't know. I don't want to do some math right now, but I'll do it if you're ready. Oh, it's 3 LEDs. Let's do a 3-bit binary counter then, right? So that'll be either a lot of if-else statements, because you know what the truth table is. That's just a lot of if-else statements, right? So if you're really talking about a binary counter, we'll have, let's say you have your one input right, or number. And you're gonna have three outputs for our three-bit binary count, right? You'll have X, Y, and Z. Right? Right? So let's say if you imagine that 0 means LED is off, right? And 1 is LED on, right? And let's say this is our MSB, or the most significant bit, and our LSB, our least significant bit, right? So if you'll say if it's a 3-bit binary counter, it's 2 to the power of 3, we have what? 3, 4, 8 different things. So like 8 numbers, right? So you have 0, 1, 2, 3, 4, 5, 6, 7, and 8. Yeah?
Oh, so did you get rid of that?
Overflow. Right? Now, our 0 values will be all zeros. So to 0. So all the leads are off. And then we're gonna alternate 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0. 2, 4, 6, 8. Oops. I put too many.
Well, just do the power of 4, so you have 4 pairs.
Yeah.
I think you have 4 pairs.
6, 7, 8. Yep. I put 2, like 2 points. Okay. Let's try again. 0, 1, 0. It should be 3 pairs. 0, 1. That's nice. I think. Hey, I could be trolling. 1, 2, 3, 4, 5, 6, 7. Yeah. I'm trolling right now. Okay. And then I have 0, 0. 0, 0, 1, 1, 0, 0, 1, 1, and then 0, 0, 0, 0, 1, 1, 1, 1. Meter. And it's our overflow bit. Yay. We can't do this one. Okay. So now this is our truth table, right? This is how our logic is going to be. We'll have 3 variables for the 3 different pins. And you guys want to do a logic circuit for this using AND gates or OR gates, and then make the actual logic in the if and else statements? Yeah? Oh no, okay. I don't want to do that right now. So it's been a minute. You know, as a not ECE major, it's been a while, guys. It's been like how many years? 6 years. Okay, that's crazy. Okay, anyways. Yeah. So you're gonna be using, let's say, our toggle, right? Our button. Every time we press the button, we're gonna be going off and on this one, right? So our toggle, our button press will toggle your last bit on and off. That's an easy one. That's something we can do easily, right? Our next one though is only if, let's say, when this switches from a high to a low, it will become a 1. It's a falling edge for your guys. Ooh. Yeah. Okay. I want to do one right now. My face is not great. Okay. So yeah, every time you go from a 1 to a 0, so how would that be logic-wise? So if you think about it, we'll have 3 toggles, right? So in this case, it'll be if this is a 0 and this is a 1. You guys help me out on this one. My brain's not right now. It's too late tonight.
We got Wayne Allen.
So this is the easy one, right? Simple toggle. So here we're doing is a falling edge, where once this toggle goes from a high to a low, this will go to a high. Only when that goes to high to low, I will go high. I just copy that format on this next thing. We gotta store, in a way, you gotta store the previous memory, right, of this and the new one. That's one way you can do it. It's money with doing. So, in short, I don't want to do this. Okay. Anything else though? It's not as complicated and like my brain's gonna die. And it'll take me a few hours to figure out right now. Unless you want to do it.
Do what?
This.
That?
Yeah, make the battery count in code.
But like you, shoot. So, I mean, like you said, it's gonna be a bit off, or because, I mean, you're gonna have to say the previous state. What that is true, you do have to say the previous state. And I do, I mean, because what? I think it might be wise to not do it.
All right, cool. Sounds good. We're not gonna do this, guys. Okay. What else do you want to learn? I had your in your hand was up.
This is probably.
The Python code? Okay, so for that one, we're gonna do is we're basically gonna open the serial port of the Arduino and your computer. Okay, and that way we can kind of send a data. So let's do that. Let's basically send the data from your Arduino to your computer and display it on your terminal window. Right. So for this one, do you know Python?
No.
All right, sit back and learn. Okay, so we already have this code already here, right? So let's say we want to send just one value, the brightness, how bright it is, right? So let's first make that happen on our code. So in our serial print statement, right here, or our setup, sorry, not serial print. We'll do serial dot begin, colon, or parentheses, and we'll do 115,200. This is my favorite baud rate. This means how many times will it sample? How many bytes will it sample per second, right? So this is my favorite one because fast and it's pretty fun, whatever. But people use 9600, it's too slow. Anyways, so and now on your code, right here, we can do a serial print line saying, let's say, at the end of this, we'll do serial dot print ln, and we'll do LED. We'll print LED is we're gonna do our brightness, or we'll do actually let's see, we'll do LED brightness. And then serial dot print ln, and we're going to put the value for the brightness, which is B. Right. So what this did right here? What we just did right here is we made one. So ln just means line break at the end. So what we just did was we printed out LED brightness and then printed the actual brightness in one statement and put line break at the end. So if we compile and run this right now. And then we see the serial mode up here. That's your debugging tool. So you can see I'm at the wrong baud rate. Well, I'm at the right baud rate. What? Did I put the wrong baud rate in here? 15200, 115,200. What? Let's see. Did I put B for binary maybe? All right, we'll do B instead. We'll do Brit again. What's happening, Brit? And then we'll do, where is B? Brit. Okay. Run this. Let's see if it changes anything. Or not. What is going on? Okay. Serial.print on. Right common port. That's interesting. do 9600 for now. There we go. So it might be that the processor here is not able to hit 105,200. So you gotta make sure that you're taking that into account. So you see right now the brightness value is that, right? But as I change the value, you can see it changing the value from to 0 almost, and that'll change how fast and or how bright it is, right? And that's the maximum brightness. It's pretty bright here. I can't show you, but because it's too short, right? That's pretty cool. But how do we send this over to the Python file, right? So I'm going to just comment out this part right here because I don't want to put that right now, right? We'll open up VS Code really quick, and we'll open up a Python. Look at Python file on this one. That is my other code. Oops. And then let's see. Let me delete this real quick. Okay. Let's give it a second. I think it's loading everything in. What I'll do is I'm gonna make a new file, new text file. We're gonna put in Python. So if you don't have Python installed, please let me know. I can help you install it later. Right? And we're gonna save this, let's say, on my downloads folder for now. And we're gonna call it hard2py. Okay. So the first thing you want to do in this case, you would be to import the serial library. That would be in the terminal window. You just want to do is go here, Python 3, parameters -m pip install serial. I already have it, so well, I should already have it. If I don't have it, we'll see right now. It's also in the wrong folder, but it's okay. All right, I have it now. So I didn't have it before. I'm gonna do is we can do import serial. That's the serial library for Python. Where is this located? Wait, did it do in 3.10? Might have been the wrong Python runtime. Let's see. Did this one. No. It's in 3.10. Okay. So we've got to go to the 3.10 file. And hopefully it'll run. That's again. I have too many issues with importing stuff, so oh my god. Okay. Can we do import the same one? That's all. Okay, there we go. All right, it should be good now, I hope. And maybe I'll just, there we go. Okay, yeah, that's good. Okay. So now that I have that, so we know that through our Arduino code, it's on port COM14, right? So I'm gonna turn off my serial monitor here. And I'll do serial. So it'll serve equals to serial dot serial colon COM port is gonna be COM, what's it again? 14? 14. And our baud rate is gonna be 9600, right? And then we're gonna do is say our value val is equal to serial dot read. I think read all read line. We'll do read line. And then we'll do. I don't know what's happening. What is that? Okay, what is this? And then we'll print now. And then we'll see if you open the terminal window. Let's see if it runs. So what we'll do is we'll cd to downloads. And then we'll do, what's it called? R2Py. So Python 3. Art2Py. There you go. No attribute serial. Oops. Let's see. It's been a minute though. Yeah, that's what it is. What's that? Huh?
You gotta do the same three of them.
I can't hear you.
But you may have to do the same Python three from the command line.
Maybe. Okay, we'll see. We'll run that and we'll first see if this will run, and then we'll go and fix that. My terminal went away. Cool. Back again, downloads. I go. And then same thing. Yeah, okay. So we'll bring this back to this, and then we will click here. And then see if this will make module is not possible. No. Okay. Let me go back to my reference code real quick. I'll be back. So we did this for the rocket. So that's why I remember doing it. So we will open a folder. That's unfortunate. Let me go up there. And what we do here? We did import socket, we recorded these. Oh, that's for I2C. So client side number 2. Serial.serial. It's not what I did. Interesting. And then read line decode, that's it. But it should have been serial.serial. So let's see. Huh. That's unfortunate. Dot decode. Well,
Serial.
huh?
Trying for the serial.
Yeah, I'm with it right now. So it's not there. I think. Maybe like from serial, import serial, and then maybe this will work. Hopefully. Well, interesting. Oh, I'm gonna fix that later, I guess. But that's how I do it on the Pi, at least, because I did do this for the Pi. Yeah. Dang, I was so close though. Almost there. But yeah, it's time to be two. So any questions? Any questions, comments, concerns? You want to learn anything else? Dang, I was excited to show you serial because it was so close. Because our code did work. Huh?
The interpret.
An interpreter? Okay. We'll see. I hope it works, but maybe it'll work. Maybe it will like. It's not running the Python file. That's the server ladder. We don't want that. Okay. So I could just. Okay, see. It's in the wrong folder. I'll just reopen VS Code. Maybe that'll fix it. So that's in the wrong folder. That's the wrong folder again. But yeah, it's not running on. Something's wrong with my VS Code or my Python. But this should work. Yeah, because it does work with the Pi. And again, I have video evidence for that if you want to see that. I can show you again. And because what we did is we got the data through the serial, right? And then we put into a text file and we formatted that. So that I can show you is in our. We can also go to two serials for this. So that is for this one here. So here we used serial 1 and serial 2 for this code, but I delete that. So, but yeah, and then we got data, which is in the yeah. So in the end, we got data. This is our data from Arduino from 300 feet away. So yeah. Yeah, I can't show you the real data because it's classified, kind of, but yeah. Or terminal window?
Yeah. If you just.
Okay.
Just like.
That's not what I do. Oh no.
Oh, see. You know, do some, so.
But I'm using Python. I'm using Python 3 though. Shoot. Wait, I mean. But I do Python. I want Python 3 at 10. So yeah, so I'm using Python 3 at 12 that way. So if I do exit into Python 3. 12 and one are
just you can go Python 3.
I'm just copy and paste then. Does pasting work? Paste anyway.
Terminal, that should.
They're not defined. Set.
Oh, this is called serial.
Oh, serial dot serial. And we do 14, 9600. Bam. What do you mean? Try again?
Yeah.
Oh.
Serial.
Oh.
In second. Yes.
Yeah.
Yes.
So for serial, I'm gonna do serial is serial dot serial dot 14. Nice. That won't be it. What attribute does serial have then? Interesting. I wish.
You trying to man page?
Hmm?
Or what,
I'm just gonna
or, sorry,
press serial.
is this not an external?
Oops.
Or is it?
Huh?
I was asking if it was an external terminal.
No, all it was, but the serial dot. What do you have? There's a serial thing right there. And then we have the port and the string, so. 14. Comma, 900. And then we're doing that too. Serial. That should be pretty simple, like it doesn't figure it out or anything. So, but this should work, technically. Then just like seeing in Python 3. Okay, something to do in modules. Yeah, but I know for the Pi it works because I've done it. So I have proof of that. Other than that though, that would be a way you would do it. But yeah, this is better for like Pi's and Arduino's thing that to their computer. So
So we won't have this workshop.
after this, I don't think I can't do it after like I'm too busy to kind of handle my aerospace stuff and then my projects and it's kind of hard. But if you want to learn still, like just DM me, I can probably tell you something or the other. So if you want, like,
Chat, Discord, we might as well do something.
yeah, just keep chatting on the Hyperloop Discord. Maybe I'll
Yeah,
see
same
you.
time or something. Yeah.
Yeah, and or if like maybe one day if I'm free and if you guys are free, we can do a small pop-up workshop.
So
Is it because you guys are graduating?
I'm not graduating, but I have to focus on graduation. I have to focus on my graduation, so I'm kind of like,
So he has to finish his class too, right? So as in, keep up with the years.
yeah, it's getting kind of hard to balance everything else out.
Look, here's
And
what we
our
can do.
projects.
I have a bag, you get the bag, we get from class, What do you think? I was joking, if you have a bag, I have a bat.
You're gonna beat me up.
No, we're just gonna
Hey,
abduct
yo.
you.
Hey yo.
If you want, you can also check out our, YouTube, we got like years worth of workshops.
Yeah, we've done the Python workshop, which I know will work on this one. We did the Python workshop. That's the OpenCV one. So Python 3. I know it's not Pi, but this one here is gonna be camera and facing. So that's on the internet, so you can use that.
Oh,
That was one of the OGs Python workshops. That is the one we can see. CV Hyperloop.tech, I believe. I think. That's from my web camera. Yeah, my web camera. Yeah.
So yeah, so I put here workshops.
If you want to take your stuff.
Yeah.
Yeah. But yeah. Thank you guys for coming today. At 8 p.m. Class is dismissed. You can go now.
Oh, workshop.
You haven't been dismissed on this one?
yeah.
Bro, I'm reading a few hours, like, logically, it's worked out.
Pretty good. Or I mean, I like this. You should see the older one.
But you think that's
here.
high. Oh, yeah.
I'm not sure.
It is just, it's like a logic.
But it's like the last two seasons were pretty good.
You know what, Jameson, if you want it, you can take it. What do you mean?
Yeah, that's right.
Hey, you're missing out, though. Breadboard, LED, that's all left.
It's like we have a bigger breadboard. Bigger one.
Okay, buddy, come on, man.
I only a big
LED. You guys have to return the kids?
They didn't pay for it, so.
Yes.
Because we already got the third considered workshop, and we could pay for it. I don't want that, so people who already paid for it, like, they're free now, like.
Oh, yeah, I know, for sure. I just wanted to ask, when will this video be uploaded?
Oh, by the way, did you get an Arduino?
Well, I didn't shoot that.
It's okay. You came to the workshop. All right, see ya.
Hopefully this weekend.
Hopefully, sometime. I should probably start recording right now. Oh my god.
You didn't know? Was it? No, you started?
No, I mean,